Welcome to the Ultimate Python Animation. Module 1 covers core syntax, input, output, and types. Variable assignment in Python is dynamic and straightforward, requiring no explicit type declaration. Python uses block indentation to define scopes, replacing curly braces found in other languages. The primary data types include integers, floats, strings, and booleans. The print function outputs data to the console, our primary form of basic I/O. To receive user input, we use the built-in input function. Comments start with a hash, while multi-line documentations use triple quotes called docstrings. The string function provides a readable format, while repr gives the precise representation. The help utility provides built-in documentation for modules, functions, and classes. String formatting is best done using f-strings for clean, interpolated text. Strings have many powerful built-in methods like strip, upper, and lower. That's the core syntax. Next up, math and operators. Module 2 explores mathematics and operators in Python. Addition and subtraction are fundamental arithmetic operations. Multiplication uses the asterisk. Standard division always returns a float. Floor division drops the decimal, and modulus provides the remainder. Exponentiation is done using a double asterisk. In-place operations modify a variable efficiently using operators like plus equals. The math module includes complex mathematical functions and trigonometric operations. Bitwise operators allow you to manipulate individual bits directly. Boolean operators and, or, and not are evaluated left to right. Operator precedence dictates the order of execution, where multiplication happens before addition. You've mastered math in Python. Let's move to logic. Module 3 focuses on making decisions and repeating actions. Conditionals use if, elif, and else statements to branch execution. Comparisons check the relationships between values, returning a boolean. A while loop continues executing as long as a condition remains true. A for loop iterates over a given sequence or range. Using loops within functions helps isolate logic and keep code modular. Variable scope determines where a binding is visible. Variables inside functions are local by default. Control flow allows our code to be dynamic. Module 4 dives into grouping and structuring data. Lists are mutable, ordered sequences of items, functioning as dynamic arrays. List slicing extracts subsections of a list rapidly. List comprehensions offer a concise way to generate or map lists. Tuples are like lists, but they are immutable and cannot be changed. Dictionaries store data in key-value pairs for extremely fast lookups. Sets automatically enforce uniqueness and allow for mathematical set operations. Multi-dimensional arrays are easily represented as lists containing other lists. The enum module provides symbolic names bound to unique, constant values. The filter function extracts elements for which a condition returns true. The heap queue module implements min heaps for priority queues. Group B from itertools aggregates sequential identical elements. Unlike lists, linked lists use separate node objects holding references to the next element. Copying data must be done carefully, often requiring the copy module to avoid reference bugs. We've explored everything from basic lists to advanced structures. Module 5 takes us into functional programming and advanced syntax. Functions are reusable blocks of code defined with the def keyword. Passing lists as default arguments can lead to persistent state bugs across calls. Generators use the yield keyword to produce values lazily, saving memory. Iterables provide iterators, which track their position and produce next elements. The map function applies a transformation to every element in an iterable. Reduce continually applies a function to compress a sequence into a single value. Partial functions let you pre-fill arguments of a given function. Decorators wrap functions to extend their behavior without modifying them directly. You are now wielding advanced functional concepts. Module 6 covers object-oriented programming, files, and pattern matching. Classes bundle data and behavior into single objects. Metaclasses are the hidden blueprints that define how classes themselves are constructed. File operations are safely handled using context managers. The OS path module handles cross-platform file paths securely. Regular expressions allow for extremely powerful text pattern matching. Objects, files, and text patterns are now in your tool belt. Module 7 reveals the massive power of Python's standard library and modules. A module is a single file, while a package is a directory of modules. The collections module provides specialized data structures like counters and default dicts. The operator module exports built-in functions corresponding to standard operators. The JSON module serializes Python objects into JSON format for web APIs. SQLite 3 provides a lightweight, disk-based database requiring no server. The OS module interacts with the system, and locale formats data for different regions. ITA tools and functools supercharge your functional programming capabilities. Asyncio provides asynchronous I/O and concurrent code execution. The random module generates pseudo-random numbers. The dis module disassembles Python code into its underlying bytecode. Queues and dequeues provide thread-safe, fast appends and pops from both ends. Web browser opens URLs, while Tkinter allows you to build desktop GUIs. Third-party libraries like PyAutoGUI let you automate mouse and keyboard inputs. You have barely scratched the surface of Python's ecosystem. Our final module touches on algorithms and data visualization. Searching arrays can be done linearly using the in keyword. Sorting and finding extremes is optimized via built-in C functions. Counting occurrences is easily achieved using the list count method. Libraries like Matplotlib and GraphTool unlock massive data visualization potential. Finally, the datetime module masters all temporal data, tracking exactly when our code runs. You are now a Python master. Keep coding.